Okay, thank you very much. Of course, my topic is the most sexy of all of them. So I'm a computer scientist by training, and what I usually, depending on where I am, but what I used to call myself was actually a web plumber. So I had that on my door when I worked in the School of Information. So basically my spiel was that it's important that information and services can basically flow around, and to do that you need infrastructure that allows you to do that, to couple things loosely and all these kind of things. So what I want to do today is basically talk a little bit about that with the topic of data science and data lakes that you hear so much about is, I think, something where you can look at nice parallels to software days when people were also building very complicated software systems on data, which back then was called enterprise application integration, or whatever you would like to call it, enterprise software, right? And there was this area of transition where this software was built on big databases, and it was very hard to change any of that, and then all of that transitioned into sort of the agile landscape that we have today, where people try to be more isolated in terms of how closely they bind different parts of their functionality to each other. And I think there's a nice parallel to what you see in data science happening now, where you can also see that right now a lot of really interesting things are happening working on one big data source, and that's exciting, and you can do a lot of useful things. What I want to do today, and basically that's all I'm doing today, I think, is want to make a point that even though that is one way to do it, there's another approach that you can also take and say, instead of collecting all the data and working on it in one place, which can be very convenient, you can also look at a more sort of isolated landscape of having different parts in your system where you do that, and then you connect them based on what you want to do where. And one typical example for that might be, for example, car automation, right? When you look at your car, creates a lot of data, but nobody would really want to have sort of data science approaches being used in a centralized place if you want your airbag to deploy, right? You need to do that in your car with very low latency, and you need a lot of data for that. So in that case, naturally, you kind of isolate that thing into a separate system, into the car, and you do whatever you need to do there. And then maybe you build that system so that when the airbag actually does deploy, you have, let's say, the last minute of data so that you can analyze it and maybe learn something from it and these kind of things, right? But that is one example of how you might want to separate things in terms of collecting data maybe in one place, but also using it or using subsets of it in a different place and building sort of a service landscape that allows you to do that, right? Where in the end, you would have some sort of analysis service in your car. Cars have interfaces these days, right, where you plug in your car analyzer, and that reads out the last minute of data that you have, and maybe you can learn something from that. So that's basically my main topic of today, trying to motivate that this is something to keep in mind when you work on projects around data science, working with big data, getting insights into data, that it's one possibility to do all of that in a centralized way. But it's not the only possible approach, and it does have certain consequences to do it that way. Sometimes that's fine, sometimes maybe not so much. And as a data scientist, I think it's important to also have this kind of knowledge, not just about what to do with data when you have all in front of it, but what to do in terms of handling data when you have a big landscape of distributed things that all generate data, need data, process data, and you want to manage that landscape in the most efficient way. Okay, that was a very long introduction. So very briefly, just where I come from and why this is a topic that fascinates me, and that also kind of is something that I have worked on in different forms over a long period of time. So my background is, like I said, I'm a computer scientist. I did my PhD in communication systems, internet communication protocols. I started working on web technologies when the web sort of became more important, more popular, late in the 1990s, early 2000s. And we worked on web technologies in a variety of ways. For example, when we were at the School of Information here on campus, we had a little project where we were trying to influence a little bit how this whole idea of open government may play out. Where we had this idea that yes, open data, open government, that's something that's nice. So you want to have more of the data that the government collects because then you can do something with it and you paid for it anyway, right? And a lot of the architecture that actually, well, eventually ended up being implemented, sadly, I think, was not so much really a fluid data architecture where you would actually learn about things as they happen, but more data dumps, right? At some point, somebody in the government decides, okay, now we release this much data, we give it to people that can play around with it, right? And that's one way of doing it. And there are a variety of reasons why you might want to do it that way. But there also could be approaches where actually it would be a more dynamic interchange where the government actually presents services, right? Where you can use those services, you can request certain data, maybe you can get updates, right? And all these kind of things. So that was one of the ways in which we were working with sort of service models in sort of a data world. I left UC Berkeley around 4 or 5 years ago, and then I worked at EMC for a while. So EMC is a company that in the business unit I was working in, our main product was a document workflow software, so typically used in places such as banks, insurances, pharmaceutical companies, where there are a lot of documents flowing around that need a lot of process behind them, where somebody applies for a loan, there needs to be a certain sequence of steps before the loan gets approved or rejected. All of that needs to be controlled and archived and all these kind of things. And what I was working with was mostly the idea of taking that product, which in the beginning was something where people would just enter the data and everything would just happen, and build APIs for it. So customers were increasingly demanding to have APIs because they wanted to add more functionality to the product and say, yes, our workflow is fine, we still like your product, but we also need to have some ability how we can either get information out of it or maybe get additional information into it using products that you don't give us. Right. So there the main thrust was that the product had to be opened up so that people could actually do what they wanted to do. And that it was very clear that customers wanted to do that, or they would just at some point ditch the product and say, you know what, we need something that is more open. We have a lot of data flows that are not just in your product, and you need to do something about it. Right. So that was another sort of angle of the whole data and service topic that I'm usually somehow working on all the time. And then the last company I worked with was Siemens. Siemens is pretty much, you all heard the presentation last week, General Electric, right? So Siemens is basically the GE of Germany or of Europe, right? It's a gigantic company, 350,000 employees. It's a very impressive company. And there the idea was that we would have a small research lab here. It was just off of campus here in Berkeley. And the idea was, how can we take all the products that Siemens is making and make them better for the customers using areas that basically were rooted in IoT scenarios, so Internet of Things, so a lot of sensors, sensor data. So Siemens, for example, sells wind turbines, and then right, the classical things. So a wind turbine has literally thousands of sensors in it that measure all kinds of things. And if you do that in a smart way, in the end, you hopefully can predict better when it's going to break, and you can prevent that from happening. So that creates a lot of value. And the idea was that, of course, you want to do that, but you also want that you want to do that in a way so that customers can actually use that and not just sort of magically depend on Siemens is going to get it right? But that instead you might have a web service that a customer could, for example, analyze themselves and say, hey, I want to see the vibration data of the last day. What happened? Maybe my algorithm is better than yours, or I just want to see the data. Or if something happens, maybe I want some of our technicians to be alerted so that they can have a look. Right? So the idea was to take all that data that gets generated within products and open it up in a more web-oriented way. So this WOT thing there is for the Web of Things. That was basically sort of our name that we came up with and said it's good that things get connected more and more. But connecting then is not good enough. You also need to make them accessible so that people can integrate them into whatever they want to use them for, right? So I worked in that area for about a year, and what turned out to be the problem there, and that is A, why I left, and B, why I think it's interesting to look at how big companies are sometimes handling that, is that you would talk to those big business units within Siemens. So we would talk to the building automation unit, business unit, or to the power generation business unit, right? Which in itself are gigantic corporations, so to speak, with more than 1,000 people working for them. And we would tell them, hey, you should open up your platform a little bit more so that customers can actually do what they want to do with it, and that you become more part of an evolving system of parts that customers can rearrange as they like. And usually what they would say is, no, we don't want to do that. Like, if you have a useful idea what we can do, you tell us and we put it into our product, and then it stays there, and customers will pay us for it. And that's all great, right? And of course, from the business point of view, there's a point to that, right? If you can do that, then it's good. You have a better product. Customers may give you more money. You might have some advantage over the competition. But on the other hand, it's very hard to imagine that you can really identify and implement all the areas where people might want to put some additional value into those things, right? So there's a balance between trying to always keep everything centralized and do everything yourself and build the platform that everybody has to use and that does everything, and between more open and trying to give people more of a toolbox where they can plug things around and they can say, hey, I want to implement that myself. Just give me the raw data. I think I can do a better job, or I have another solution over here that promises me to be better than this other thing, right? So that was the last thing I was working on, and basically in all of these places, the main thrust was always the same. It was the idea that in the end, what really matters is not so much the data itself, but what you can get out of it, what you can do with it, right? And then those are things that in most cases you can frame as some kind of services, right? And then you can plug those together and hopefully do something with it. So, like I said, I want to basically start a little bit those explanations from where enterprise software started quite a while ago, and how that developed, and how sort of the complexity and also the realities of how easy it is to evolve those complicated systems, how that eventually led to the idea or the realization that building those big platforms may not always be the best idea, and that there definitely are problems with it. So let me start with talking about just a little bit how all of that started, right? So when the whole idea of basically running your whole corporation off of software of some kind started a long time ago, not data science, but basically basic business processes, right? The traditional modeling and software development method was what today people call the waterfall method. So I guess all of you, who hasn't heard of the waterfall method? Everybody has, right? So it's basically this idea of very heavyweight analysis of what happens, then you model a system that somehow represents that in software and data, and then you build that system, and then you claim victory. And in theory, that's nice. In practice, turned out it's not very successful in many cases, because in many cases things change while you're doing that. And then you don't really have a process in place how you can tweak things easily, because you have this very heavyweight development process where things are not isolated very well. And if you want to change anything, you basically have to change everything, right? You have to, if you change something here, you have to make sure all the other things don't break, because they often do if you don't. So it turned out, right, that working towards this perfect stable IT is not really a reasonable goal to have. It's not really something that you want to do. And that, of course, gets more true every year, right, with companies restructuring themselves and acquiring new companies. and having to rearrange their infrastructure at an increasingly fast pace. So the idea is really that in order to tackle that problem, right, you want to isolate things in a better way so that you can switch them out, change them, throw them out without having to change the whole system all the time. Right? That is basically what was this big change from this waterfall method to agile, or whatever you would like to call it, right? To software development methods that just try to better isolate parts so that you don't have to be afraid of everything falling together once you change one little thing somewhere, right? And so the waterfall model really turned out to be problematic, mostly also because it assumed that there is a reality out there of how things get done, and if I put enough effort and money into capturing that reality and representing it in a system, then I win, right? That was kind of the underlying assumption, right? And that usually isn't true, right? The way how things are done changes, or the way how you want to do things changes. So it's really hard to capture that one true or build that one true model. And like I said, right, newer approaches are trying to kind of replace that. And one of the really important things in there, and that is basically why I kind of use that as the introduction to my claim that in the end services are more important than data, is that at some point people said one of the important things that you have to take care of is that your business logic, the kind of things that you do, is not directly coupled to how we actually store data in our database, right? Because we have to rearrange data and change it and add data all the time. And if everybody works on the database directly, then that's one of the things that always happen again, right? Somehow the database schema gets changed and then everything just falls apart. And there are different ways how you can approach that. Database technology improved a lot. There are different kinds of database nowadays that also try to improve that a little bit. And then also software development methods try to be more careful in terms of how much your business logic is actually directly coupled with how you represent data in a database, right? And what happens nowadays is really that you try to isolate those things as much as possible so that they can evolve independently, right? And that basically, in order to use a certain business service that does something for you, you don't need to know how it does what it does, right? And it just magically works, hopefully. And my claim is that data lakes, to some extent, are a little bit like the good old enterprise application integration idea, right? Where you say, there's one place where all the data is kept, everybody works on that one thing, and good things will happen. And that is true, right? I mean, that can happen, and it's being done, so apparently it works. And data lakes themselves, right, have sort of a long history, so to speak. They used to be, or something not quite as nice, but used to be called data warehouses, right? So people were doing that already, only in a probably less flexible way. But still, the model nowadays, or today, kind of remains the same, that you have this one place where everybody goes and does their analysis and then gains insight into the data and these kind of things, right? And that just creates certain constraints, right? It creates constraints sometimes in terms of how fast you can update data, right? If you have high volume streams of a lot of data, at some point you just get into problems. I mean, it's very amazing what you can do nowadays with systems, and there are specialized systems trying to do that even better. But it's just, at some point, it just becomes a question of scale and also of cost. Right? At some point, it just becomes very expensive. And then the question is, do you really want to pour more resources into trying to collect all your data in one place, or is there a better or a cheaper way of doing that? Do you have a question? Sure.
So what does this mean for Teradata, Netezza, and the EMC asset, the data warehouse? So, I mean, do they have a place in your vision of the enterprise data architecture, or is this just kind of now legacy technology?
I would call it legacy technology, and then I think there are a lot of scenarios where you can definitely make that approach work, and technology also, having learned the old EAI lessons, has become much better, and making those data lakes definitely much better than data warehouses, in the sense that they often are, and I think I have it on here, right, are schemaless and these kind of things. But it still is something where it just, there are some things you can and you cannot do in those platforms, right? And then the question is, if you run into those areas where you say, well, I cannot do that in that platform for whatever reason, right? What's the plan that you have, and what's their ability to actually still work with you and make it work, instead of just saying, no, just wait, we can also do it in a year or two, right? So I don't think they're a legacy. I just think that that's what I also was referring to when I was talking about sort of the old school business units in Siemens, that there's this natural tendency in people who have worked in enterprise software for a long time, that they want to build a system. That's just their impulse. I have a problem, I need to build a system that solves that problem. And my main counter-argument is always, like, what you really want is an ecosystem of things that basically can develop, where you can put new things in, you can take them out, it kind of can evolve over time. And there's not necessarily a single point of control, but instead you have an idea of how those additional components can be added and can be taken out. Yeah?
Yeah, so on that point, when you say that you want to build a system, it sounds a lot like you're saying there's not much of a modular approach, or there's not much of like like our phones. There's an ecosystem, you can add apps in, you can add apps out, but then at the end, they all runs inside that ecosystem. Mm-hmm. Are you talking something like that, or do you mean something like you have an SAP that's one big system and you have certain smaller modules of it, and they try to add in or out?
I think these are two different layers. The people who build complex systems nowadays often do it in a good way, right? I mean, these systems are very, very complex, so you need good software engineering to actually make them manageable, and then all of that. But it still often is this approach that, yes, if you want to play with that platform, you have to plug into it directly in exactly that way. Well, thankfully, in some of those platforms, at least, right, on the iPhone, for example, right, you have an app model, so you can actually have sort of a pluggable model. But as you can see over time also, right, it actually took Apple a couple of years to really come up with all the APIs in that ecosystem, right, where you had access to, I don't know, things like the address database. And then they realized, oh, actually, it's kind of bad that apps can just read all of the addresses, because then app developers just do that, right? So maybe there should be an API where actually users need to grant access, so that the apps cannot just suck out all the context if they feel like it, right? So that, I mean, there is this architecture of how you allow those components to be added, sometimes as part of the system running in it, or as part of the system, part of the ecosystem then being more network connected, right? But in the end, what you need for this to be evolvable, so to speak, are that those APIs provide enough functionality that this ecosystem can do interesting things, and not just the platform owner can develop things, and if they don't do interesting things, then basically as a platform user you have no choice, right? There's like, you can just say, well, I just can't do that. So, right, and Apple has, I mean, they definitely have, if you look at sort of how the API complexity increased through the different iOS versions, right, it has become much more powerful than it used to be, because they realized how much more value actually can be created for people using apps when the apps can do more things. So they added more and more functionality, and then sometimes they had to backpedal a little, and sort of an incremental exercise. Any other questions? And definitely feel free to interrupt me anytime. Okay. Data lakes. So like I said, that's basically my one big message to you, is just saying that data lakes are not the only thing to do, because in the end, the data lake itself is not that interesting, right? So this is the data lake today. Anybody realizes which lake that is? Crater Lake. You should all go there. It's really nice. It's a very nice lake. Very big. a lot of stuff in there, right? But in the end, for data lakes, right, you're not really that much interested in all the data, right? That's not really what you're interested in. In the end, what you're interested in is what can I do with it, right? What value can I realize? And there are some problems with data lakes. And I guess maybe I can even scroll here. Yes, I can. So if you look at some of the interesting or the usual properties of data lakes, right? So volumes, right? It definitely can be problematic if you look at data volume. That sometimes, like I said, let's look at cars, connected cars, right? Like the number of sensors you have in a car, you would not really expect all that sensor data from all cars going into some big data lake. I guess that would probably, even for big car manufacturers, would just become a little much, right? So to some extent, right, the cars already are this natural boundary, right, where you just say, okay, I need that data within the car to operate the car, but that's fine. And then the data that I get out of the car is much more coarse-grained, right? It's like, what's the fuel consumption? What's the what's the mileage of the car, and these kind of things. Another thing that often may become problematic in data lakes, depending on what you want to do, is velocity, right? So if you really need access to data very quickly, then first sort of mapping it into whatever your lake is made out of, and then putting it in there, and then finding it, and then doing something with it is just not something that can be reasonably done. Like the example of the airbag, right? If you have those things that need immediate action, you probably need a different architecture. Variety is another thing where, in many cases, if you have different data sources, so for example, one of the things that we had where it also became apparent that people sometimes have different mindsets, when we were talking to the people in building automation within Siemens, was this idea that, yes, you can have all kinds of sensors in a building measuring the same kind of thing, temperature, humidity, CO2, whatever it is that you're measuring. But if they are from different manufacturers, right, those data streams actually might look very different because they were just built differently. And then in the end, what you're probably not interested in is to really look at those raw data streams, or mostly you're not interested in. But you sort of want a harmonized view of that, because in the end, what you're interested in is the temperature, and not so much how did that particular manufacturer measure the temperature, right? So sometimes it might also be good to say, well, before I actually put things into there, I want to kind of harmonize them into a common model so that it's easier for somebody doing work on the data lake to not have to care about those implementation-specific differences. Variability is another important thing, right? So data cleansing, these kind of things also very often you want to have these kind of processing pipelines where you look at the data first, you filter out based on whatever you're doing. Sometimes very important, for example, within EMC, we ran, that was very an eye-opener for me, regulation. So a big set of customers for EMC was pharmaceuticals, because in pharmaceutical you have all these test protocols, how to test new drugs and all these kind of things, and a lot of that is actually heavily regulated. So you need to write down when you tested what the results were, all of that need to be archived, time-stamped, everything, right? And also it's very important where you do that. So sometimes you're not allowed to actually store those things in a different country, right? It's just not something you can do. There's legislation around that. So in those cases, right, you might just have to say, well, okay, if the legislation tells me I cannot store this data out of the country, you have to come up with some plan how you can actually do it. So what EMC ended up doing is they actually were starting to build data centers in different countries because they had to. They wanted to provide services. And customers would just say, yeah, it's nice that you have this data center in somewhere in Nevada, but we cannot put our data there. It's just not, it would be illegal for us to do it, right? So that is something that might also be a big roadblock. And then experimentation, right? If you just want to play around with stuff and maybe you want to see, well, what happens if I do this or this, and then how can I throw together maybe a different way of looking at the data, then having a good way of how you can sort of create sort of little alternative reality data lakes is a nice feature too. So my claim is basically that this is sort of the future of data lakes. with like the rice terraces, where basically what you do is having a good idea of what you need where, how to connect things so that you maximize the yield, and having a very strategic model of how you connect those things, right? And sometimes it may end up being that you say, well, I'm draining all these pools and still have only one big one because that's all I need, right? But at least having this in your mind as an architectural choice you could make, I think that's really my main message, right? That just having one data source that you work on is a sort of overly simplified model for the reasons that I just listed. And that maybe is a more accurate, or let's say a more flexible way of approaching things. And that is also something where some of the big vendors then probably become also a little nervous, right? Because they see, well, yeah, but what if I'm selling you this little pool here, and then you like that one better, and you start pouring more and more water into there, and then what happens to me, right? And of course I say, yeah, well, if that's the picture of what's happening, and you don't produce that much yield in your pool, then, well, you have to work on that, right? So in the end, my message is, right, what matters are what you actually can do with the data. So in the end, this whole idea of that you collect your data in one place and then do something with it is not really because people like data so much, right? Because it just turned out that if you do that, you can do really interesting things with it and you can create value. And my claim is basically that with the alternative architecture that is more open to different ways how you can connect things, you have more options how you can do that. And it's perfectly fine, I think, right? If you also, in many cases, maybe say, well, that's all well, and it kind of looks cool, but we don't do that because it's too expensive, or we don't feel like we have to, or anything, right? It's basically, to me, the most important thing is just consider that as an alternative way of structuring data and working with it. Because in the end, right, even also data lake is nothing but a tool, right? It's one way of how you get access to the information that you think you need to produce value. And that information doesn't need to come from one place, right? It comes from a lot of different services often, right? And maybe the ability to rewire those things in a more flexible way can actually get you to solutions that are better than the centralized ones. Right? And my claim really is that what you saw with enterprise software, this whole wave of centralizing everything into the one big Oracle instance that runs and every data is managed in that, right? There's a reason why that pattern, at least in part, failed, right? Where the big enterprise software manufacturers just couldn't do all the things that you might want to do, right? There were just other companies that did certain parts of the enterprise data management better. And it made a lot of sense for companies to say, we want to be able to mix and match those different pieces of software. Otherwise, we have a hard time if we can only buy services from that one company. And if they don't implement a certain functionality, we just have no way of doing it. Right. And the other thing that I found very interesting is 2 or 3 weeks ago, I was at the web conference. So there's a yearly web conference. This year was in Montreal, in Canada. And one of the keynote speakers was Peter Norvig. So Peter Norvig is the head of research at Google. And he talked about semantics, right? So how you get to meaning out of data. And Google, of course, does a lot of that, right? And they're very good at it, right? They have a lot of good people working on it. But even Google, who are very good at it, and who I'm sure put a lot of resources into making that work as good as they possibly can, because that's really their main source of money. Even he said that for the really big data sets that they collect, right, and they have a lot of individual data sets internally that they work on, even for they, in many cases, they realized that there was quite a big of bias in the data. So they did one thing with the data set, figuring out certain profiles based on click data and trying to figure out what to do with it and how to better serve ads and these kind of things. And they thought that because it was click data and this and that, they could actually also do something else with that data. And then in many cases, he was telling a variety of stories, right? They just realized that if they wanted to repurpose the data, it actually didn't work so well anymore, because they had some idea what to collect, how to represent it, how to make it structured in a way so that they could use it for their primary purpose. And then when they wanted to repurpose it, they realized that, hey, it's not that easy. Maybe we need a different data source, or we need to have more data, or so. So in the end, it also was a lesson in saying that just collecting data for the sake of it and saying it's just data and I can do with it whatever I like is really not something that most often happens. Most often there's certain, and maybe it's implicit and not quite reflected, but there's a certain assumption why you collect the data and what you want to do with it. And when it changes, suddenly you find yourself in a spot where you say, hey, I probably need to tweak things here and there because I really can't do that well what I now want to do, right? And the more flexible your architecture is, the more likely it is that you can do that without having to start from scratch, right? Or having to ditch your current solution and for something else, right? And say, oh, I used that platform, but it can't do what I want to do now, so I have to change platforms altogether.
Just a quick, so Google's already in that rice field architecture then?
Oh yeah, I mean I don't know how
Yeah.
how it's looking,
Okay.
but yeah, they definitely have all kinds of different data sets they are collecting and different teams that are working on it, and they're constantly refining the ways and basically in which they collect those things, and also realizing that even though ideally they would like to have this, right? Where do we have it? This, right? That is really very hard to do, and it's very, very expensive, and it's hard to change things. So if you start being more flexible, it allows you to more easily kind of correct your mistakes when you realize them. Greg, yeah? Same question? Okay. Yeah.
Could this type of architecture also be kind of right, like a segmentable blockchain almost? Like if you have an immutable record of everything, but then you can divvy up portions of the blockchain to.
Well, that would be so basically that you could track that you could follow the data upstream and
Right.
be sure that it hasn't changed. You might be able to do that. That would be a super fancy version of that. So for now, I would just assume, there's basically a simple filtering, aggregation, combination, whatever way of how you kind of take whatever you want to get out of those individual pools and put them into a new one. And then whether you need these kind of things, and sometimes it may be very important, right? So for example, if you have, again, the pharmaceuticals right there, it's very important that everything needs to, you need to have a record of where everything comes from, right? And then that would make this thing probably much more expensive to build if you want to do that. Yeah.
So Marriott's reservation system is still on a mainframe, as is American Airlines, as is Delta, and they haven't changed that in 40 years because it's the beating heart of the company. Do you see the data warehouse as that to the Fortune 1000 today? I mean, how long will this change happen? Can it happen based on how critical these processes are to business as usual?
It's not that I think that those companies who have been using these systems for decades, right, will just throw them away and buy or build this, right? But it's more the mindset that if you would be somebody who was had the architectural oversight, that you would try to get to a picture that's more like this, where you can say, hey, if we have people who can give us insight into how is the reservation behavior going to be expected in the next month, right? So if we have these kind of things, we should have an easier way how we can maybe also add this information into our system so that we can take advantage of it instead of just having to say, but maybe somebody can give us the data, but we have no idea what to do with it. Right? Yep.
And so I was thinking about what you were saying about the data lakes and what are the good and the bad things about it. It's kind of like stuck in my head. One thing that I wanted to ask you, I don't know if there's a simple way of saying this, but if I'm like starting a company or building my own data system, what are kind of like the business questions I should ask myself to see what kind of architecture works best for what I want to do? In the sense that how do I know that for me, a big data lake is the big way to go, or the rice field is the big way to go? What does that influence on my business, or what are like the key parameters I should choose?
That's a very good question. Next question. Well, I think for playing around, it's always very convenient to start with that, right? To basically just say, okay, as long as I want to do proof of concepts and just get off the ground as quickly as I can, that is probably a good approach because it's obviously it's simpler, right? Structurally speaking. On the other hand, I think more and more you might realize nowadays very quickly that, hey, if I can actually use this from over there and this from over there and this from over there, then I can actually do things I otherwise couldn't do. And then you might be drawn into something like this almost naturally pretty quickly. But I think that depends mostly on your vision of how much other sources do you think you can take advantage of to create the value in the end? Or are you confident that you will be able to just live with that sort of big monolith and that works for you? I don't know whether that addresses your question, but I don't think it's, I mean, this thing is just something, like I said, it's structurally much easier to do and you can get those things out of the box. There are a lot of companies that sell you this, right? So that might be a good starting point. It's just that I think if you get into this idea of, hey, where do I think I'll be in 5 years, 10 years? Where will be the opportunities? Where might other companies do the same? How can I differentiate myself, right? Then maybe that's a good direction to think in and say, hey, if I'm better at connecting to other things, having a more flexible model of how I can adapt, then maybe that gives me some competitive advantage that others might not have.
Can you give an example of, like I hear what you're saying, but then when I think about that big lake, it seems like that could also be spun as very flexible.
That's what that's what's happened a lot, yes.
Yeah, so can you give an example of like why this is actually more, cause if you have this big pool of data, it seems like you can manipulate that in a lot of interesting ways versus having all these little pools of data that you need to cherry pick from. I just don't necessarily see, clearly.
And it's hard. I mean, you would need to look at, basically, if somebody wants to sell you that, right, you would need to also figure out how can I do fishing on that one, right? Like, what are the methods? So I don't have that much time left anyway, so I have, let me just go forward a little bit, which is not bad because we're done pretty soon anyway. So for example, one thing that I think is important and that sometimes get lost a little bit, the lakes are, there's not all of them are equal, right? And I don't want to say some lakes are better than the others, but they have different ways of how they structure data, how they allow you to work with the data, right? So coming up with a very probably quick and dirty sort of categorization of them, right? So you could think of sort of structured lakes as the sort of more traditionally, strongly structured data that you can sort of build traditional queries on, right? And then nowadays you have a lot of these document-based databases and sort of these platforms where you have semi-structured data that at least is open, it's schemaless, so you have more variety that you can deal with. But it's still something where basically you still have this traditional query type model. Right? And then what you also have increasingly are kind of these logical lakes where you have semantic technologies and ways of how you can basically build sort of logical models around your data and build inferences and try to basically learn from your data by reasoning. And it's pretty hard to actually have something that does all of these things well, right? So sometimes when you look at what somebody, of course, I mean, they will always tell you we can do everything, right? But that's usually not the case because there is some underlying implementation with constraints, right? And sometimes it's time they need, query complexity they can deal with, sort of the models you can do. And I think in the end, that may be one of the things that are really important, that when you think of your data and what you want to do with it, that sometimes it may be more sort of the statistical machine learning kind of stuff, it may be more the query-oriented kind of thing, and the different products, different lakes have different strengths and weaknesses, right? And if you can combine those, then it's an easier way of saying, okay, I can play around with this and see where do I get most bang for the buck, basically. And that's, well, actually, I think that's my closing, almost my closing thing, right? So I'm really, the thing that I think is important to keep in mind, right? There is no such thing as the best lake that is better than all the others, right? There's always some constraints in there in some shape or form, right? It can be updates, latency, volume, the query model, validation things, cleansing issues, right? I mean, these things are complicated platforms, right? And none of them works perfectly, which of course makes it important to really think about what you want to do with it and then pick at least one of the better ones for what you want to do. But also may make it important to say, hey, and I realize that it's not just this one lake that will make me happy for all the kinds of fishing I might want to do. I also want to try to have other platforms that I can play around with if I feel like it, or if I see that this lake is not working for me so well anymore. Yeah?
So different lakes may have the same data, but they might be structured differently. Am I understanding that correctly?
For example, yeah. If you looked at a let's say it's very traditional example of what you say, you have a relational database with certain data in it, and then you have a document-oriented database that does some JSON-based thingy, right? And then to a certain extent, those work in the same way, until maybe you want to add some data that doesn't fit into the relational structure, in which case the relational thing just completely collapses and the document database will happily do it for you, right? So, I mean, that's a very simple example, but in that case, it would be very clear that for some problems you might want to solve, it works fine. For others, it just doesn't. Okay, and, well, nothing new on here. With that, I'm done. So really what I wanted to tell you basically is that I think it's just important to keep that mindset if you're working in data science and with data, that in the end, the data is not just there, right? It comes from certain places. There are certain constraints around it in terms of quality, latency, volume, all these kind of things. And maybe just pouring it all into one big bucket and thinking that this is the best way to deal with it may not always be the best approach. And like I said, right, it is an area where you have good products and you can do a lot of things. It just, there are different architectural approaches, and my main mission really is to remind you that this can be done, that you can basically connect those, like I said in the beginning, right? So I see myself as a plumber, connecting different consumers and providers of services. And if you have a smart way of how you build sort of the individual data lake plumbing, then maybe that gives you more flexibility than you have if you don't do that.
So in other words, the data architect needs to understand not just the types of data and the types of inquiries that the enterprise is currently collecting and engaging in, but also has to have some understanding of the potential trajectory that the enterprise is going to take with respect to the types of data and types of inquiries. And
trajectory, yes.
Build out a system with some optionality that will allow it to function in a complementary way to all of those, to the enterprise.
Absolutely, and also some understanding of how the data is generated in the first place, right? Like, where does it come from? What are the different properties? How might that landscape change? Is there some, like, what are the kinds of things I maybe could do better if I had this instead of just one big place where I just dump everything into?
I guess last question is, are the vendors particularly good at kind of engaging in this customer understanding, or is it better to kind of go to third-party consultants that are non-vendors to get the best advice about how to kind of architect one's systems?
I wouldn't want to make any statements about that. I don't know really, because I've never been in the position where I wanted to build this sort of in a company and was really sort of talking to different vendors, trying to find out what they tell me. But my assumption is that usually, right, the big players basically always try to tell you, our lake is so great that there's no way there's anything else you would ever want. right? And then so the big players try to do this, and they try to maybe add some functionality here and there if they see enough customers are looking for it. The small players probably are more into this because they basically cannot make that claim that they give you the one true solution anyway. So they are more open. I think that reflects what you see in a lot of other places as well, that the big companies, right, they have much more momentum and can try to just say, well, if you go with us, that's how it is, right? And the smaller ones have to be a little bit more open in terms of saying, we give you a good solution for that slice of the problem, and for the rest, you just do something else, and we'll happily play along.
Okay, great.
Okay. Thank you.
We've got